Imagine a shape so perfectly round, so flawlessly smooth that every point on its surface is the same distance from its center. This, my friends, is the essence of a sphere. A sphere is a three-dimensional object, a marvel of symmetry in the world of geometry. Think of it as a ball, a globe, a pearl, all embodiments of this captivating shape. Spheres possess a unique charm that has fascinated mathematicians, astronomers, and artists for centuries. Their perfect form has inspired countless inventions and architectural wonders. From the grand celestial bodies in the vast expanse of space to the tiniest atoms, spheres are everywhere, silently shaping the universe as we know it. Every sphere, irrespective of its size, possesses certain key features that define its form and properties. Let's break down these characteristics to gain a deeper understanding. Imagine a line drawn from the center of the sphere to any point on its surface. This line is the radius, the fundamental measuring stick of a sphere. Now extend that radius line straight through the center until it reaches the opposite side of the sphere. This is the diameter, the longest straight line you can draw within a sphere. It is always twice the length of the radius. Picture running your hand over a perfectly smooth ball. This is the sphere's surface, continuous and without any edges or corners. Volume tells us how much space the sphere occupies, while surface area refers to the total area of its outer surface. Spheres are not just abstract mathematical concepts, they are all around us. Let's take a look at some familiar examples. The next time you shoot hoops, remember that you are handling a sphere. The ball's perfectly round shape ensures that it bounces predictably and rolls smoothly across the court. Our home planet, while not perfectly spherical, closely resembles one. Its spherical shape has profound implications for our climate, seasons, and even the way we navigate. These delicate shimmering spheres are a testament to the forces of nature. Surface tension pulls the soap film into a perfect sphere, minimizing its surface area for maximum stability. These small, colorful spheres have been a source of amusement for generations. Their ability to roll and collide in fascinating ways makes them ideal for games and playful experiments. Section 4. Unlocking the secrets, the sphere equation, in 3D space. In the world of mathematics, we use equations to describe shapes and their positions in space. These equations are not just abstract concepts, they have real-world applications in fields like physics, engineering, and computer graphics. A sphere's equation in three-dimensional space is like its mathematical fingerprint, uniquely identifying it. This equation helps us understand the properties and dimensions of the sphere. Imagine a sphere centered at a point with coordinates, x, y, z, and having a radius of r. This visualization helps us grasp the concept more intuitively. The equation for this sphere is x squared plus y squared plus z squared equals r squared. This compact form encapsulates all the information about the sphere's size and position. This equation might seem intimidating at first, but let's break it down, step by step, to understand its components and significance. X, y, z represents any point on the surface of the sphere. These coordinates can vary, but they always lie on the sphere's surface. Xt, yo, zg is the fixed center of the sphere. This point remains constant and is crucial for defining the sphere's location in space. R is the constant radius of the sphere. It determines the size of the sphere and is the distance from the center to any point on the surface. This equation essentially says that the square of the distance between any point on the sphere's surface, xyz, and its center, xy, is always equal to the square of the radius, r squared. This relationship is fundamental in understanding the geometry of spheres. Section 5. Demystifying volume, a hands-on approach. In this section, we will explore the concept of volume through a hands-on experiment that will make the abstract idea more tangible and easier to understand. The volume of a sphere, denoted by V, represents the amount of space it occupies. This is a fundamental concept in geometry and physics, as it helps us understand the properties of three-dimensional objects. The formula to calculate this is V equals 4/3 pr cubed, where r is the radius of the sphere, and pi is a mathematical constant approximately equal to 3.14159. This formula is derived from integral calculus and is essential for various scientific calculations. Let's try a hands-on experiment to visualize this materials. For this experiment, we will need a few simple items that you can easily find around your home or school. A spherical object, like a tennis ball asterisk, a measuring cylinder. The tennis ball will serve as our sphere, and the measuring cylinder will help us measure the volume of water displaced. Water. Make sure you have enough water to fill the measuring cylinder to a noticeable level. Procedure. Now, let's move on to the procedure. Follow these steps carefully to ensure accurate results. 1. Fill the measuring cylinder with a known volume of water and note it down. This initial measurement is crucial for calculating the volume of the sphere. 2. Gently submerge the sphere in the water, ensuring it's fully submerged. Be careful not to spill any water, as this could affect your measurements. 3. Observe the new water level. The difference between the initial and final water levels will give us the volume of the sphere. The difference between the initial and final water levels represents the volume of the sphere. This method is known as water displacement and is a practical way to measure the volume of irregular objects. This experiment demonstrates the concept of displacement. Displacement occurs when an object is immersed in a fluid, pushing the fluid out of the way and taking its place. The sphere displaces an amount of water equal to its volume, allowing us to measure it indirectly. This simple yet effective experiment helps us grasp the concept of volume in a hands-on and engaging way. Section 6. Unraveling surface area, a practical exploration. The surface area of a sphere, denoted by A, is the total area of its outer surface. This concept is crucial in various fields, from geometry to physics and even in everyday life. The formula to calculate this is A equals 4πr squared, where r is the radius of the sphere and pi is the mathematical constant. This formula is derived from integral calculus and is fundamental in understanding spherical shapes. Let's try a practical method to understand this concept. Materials. This hands-on approach will make the abstract formula more tangible. A spherical object like an orange. The orange represents our sphere in this experiment. Thin paper or cling film. This will be used to cover the surface of the orange. Scissors. These are essential for trimming the paper or film to fit the sphere perfectly. Procedure. Follow these steps to visualize the surface area. 1. Carefully wrap the sphere with the paper or cling film, ensuring a snug fit with minimal overlap. This step is crucial for accuracy. 2. Cut away the excess paper or film. Make sure to trim it neatly to avoid any extra material that could skew the results. 3. Flatten the cutout paper or film. This will help us measure the surface area more easily. The area of this flattened shape represents the approximate surface area of the sphere. This visual representation makes the concept clearer. This activity helps us visualize that the surface area of a sphere is the same as the area of a flat shape that can perfectly enclose it. By doing this, we bridge the gap between theoretical math and practical understanding. Section 7. From Formulas to Fun, Embracing the World of Spheres. As we've journeyed through the world of spheres, we've uncovered their perfect symmetry, explored their key features, and even learned how to describe them mathematically. We've also seen how spheres are all around us, from the vastness of space to everyday objects we encounter. But most importantly, we've learned that mathematics can be fun and engaging. By using hands-on activities and practical examples, we can demystify complex formulas and make learning an enjoyable experience. So, the next time you encounter a sphere, take a moment to appreciate its elegance and remember the fascinating world of mathematics that governs its form and properties. Embrace the joy of discovery and keep exploring the wonders of the universe one sphere at a time.